All right, so we're going to start talking about something known as the remainder theorem. And so what we're working towards is we're working towards factoring third and fourth degree polynomials. Okay? You remember from your work in 20-1 on quadratics that you solved quadratics and there was a variety of applications for doing that. One of them was to find the x-intercepts, which were helpful for sketching a graph. And we're working towards that, being able to sketch graphs of third and fourth degree polynomials. Yesterday we talked about some of the characteristics that you can determine just by looking at the equation, right? We talked about the maximum number of x-intercepts. We talked about the end behavior. We talked about finding the y-intercept from the equation. Okay? So another important thing for sketching a graph is finding where those x-intercepts are. And we can do that by factoring. So that's what we're working towards. And one of the tools that we can use to factor third and fourth degree polynomials is the remainder theorem. So we're going to describe the relationship between polynomial long division and something known as synthetic division. So you haven't seen long division in quite some time. So we'll review it. It's how you can divide. You can use long division to divide numbers. You can also use long division to divide polynomials. And then we're going to go from long division to something known as synthetic division, which is a quicker, easier way of dividing a polynomial by a binomial. So we're going to divide polynomials by binomials of the form x minus a using both long and synthetic division. And then we'll talk about the relationship between the remainder when a polynomial is divided by a binomial x minus a, the relationship between the remainder and the value of the polynomial when x equals a. All right, so there it shows you a couple examples of long division. You can use long division to divide 327 by 12. 12 is being divided into 327. And so 12 will not go into 3, but it will go into 32. It goes into 32 twice, and that's why there's a 2 written up there. Whatever you write on top, you multiply by what's in front. 2 times 12 is 24, so that's where that 24 comes from. And then you subtract. 32 take away 24 is 8. Now 12 will not go into 8, so because of that, the 7 that's left up here is brought down. And that 8 becomes 87. And 12 goes into 87 7 times. That's where the 7 comes from. The 7 times the 12 is 84, and when you subtract them, you get a remainder of 3. When you divide 327 by 12, you'll get an answer of 27, and there's a remainder of 3. So we can say that 327 divided by 12 is 27, and then the remainder is 3, which you can write as a ratio of the 12 that you're dividing into 327. Or that 3 on 12 reduces to 27 and 1/4, or 27.25. Okay, so just to show you that what I wrote here, 27 and a remainder of 3, and that is a ratio of what you originally divided into the 327, which is a 12, 27 and 3/12, which reduces to 27 and a quarter, or 27.25. Just to show that that is true, if we take 327 and divide by 12, we get, 327, not 324. We get 27.25. So that just shows you that this relationship that I wrote, 27 and 3/12, the remainder is 3 divided by 12, what you originally divided into the 327, is in fact 27.25. It just shows that that relationship is correct. Okay? Now, it also asks us to state the divisor, the dividend, the quotient, and the remainder. Okay? So it asks us to state those. So the divisor is what you're dividing into. in this case 327. 12 is being divided into 327. So the divisor for this first one is 12. The dividend is what you're dividing into. So in that case, it's 327. The quotient is the answer. And in this case, that would be 27. And the remainder is 3. So for that first long division statement, those are what the divisor, dividend, quotient, and remainders are. So this same process can be used to divide x squared plus 7x plus 17 by x plus 3. Okay? So that's what this shows. Now, remember what we did over on the left here? Every time we wrote something down, we subtracted. All right? So the key here is this first term, the first term of the dividend is x squared. You need an x squared below it so that when you subtract them, they cancel. And that's why an x is written up here. Remember, whatever you write up here, you're going to multiply by what's in front. X times x is x squared. But you're also going to multiply the x by the 3, and that's where the 3x comes from. And then when you subtract, the x squareds cancel. That's what we wanted. That's why we put an x up here, so that this x on top by the x in front gives you the x squared, so that when you subtract, they cancel. And when you subtract the 7x, take away the 3x, you're left with 4x. Okay, and then like we did over here, this 7 came down to make an 87. This 17 comes down to become 4x plus 17. So this first term here is a 4x. And we want a 4x below here that when we subtract, they cancel. That's why a plus 4 is written up there. 4 times the x is 4x. And then 4 times the 3, that's where the plus 12 comes from. Whatever's on top gets multiplied by what's in front. 4 times x is 4x. 4 times 3 is our plus 12. And then we subtract, right? We're always subtracting here. So 4x take away 4x cancels. And then 17 take away 12 is your plus 5. So we can say that x squared plus 7x plus 17 divided by x plus 3 gives us an answer, a quotient of x plus 4. And then we have a remainder of plus 5, which is a ratio of the original divisor. In this case, it's x plus 3. So there's a division statement that we can say for that division. And it follows the same pattern that we did over on the left. And so the divisor here, which is what you're dividing into the polynomial, is x plus 3. The dividend, which is what you divided into, is x squared plus 7x plus 17. The quotient is your answer, that is x plus 4. And the remainder is 5. So there's those 4 parts for that division. Okay? So, you can divide polynomials by other polynomials using the same long division process that we use to divide numbers. The result of the division of a polynomial, p at x, by a binomial, x minus a, is p at x over x minus a equals q at x, which is the quotient, plus the remainder, which is written as a ratio over the original divisor. So this statement here, this polynomial statement, is exactly what we wrote on the previous pages. After we did the 2 divisions, we wrote a division statement, and that's the general form of what we wrote on the previous page for both of those divisions. So q at x is the quotient, and again, r is the remainder. Now you can check the division of a polynomial by multiplying the quotient q at x by the divisor x minus a and adding the remainder. The result should be equivalent to the polynomial p at x. So just to show you that that works, let's go back to the previous page. Let's take that division statement there. Let me copy and paste that statement onto the next page. go. So this is what it says about checking to make sure that is equivalent to what we started with. So if I take this statement that I wrote here and I multiply both sides by x plus 3. So this entire thing on the right needs to be multiplied by x plus 3. On the left, the x plus 3's will cancel. And we have the polynomial, the original divisor, or dividend I should say, x squared plus 7x plus 17. And I should get the same thing on the right side when I multiply everything on the right by the x plus 3. Which means I'm going to multiply the x plus 4 by the x plus 3. And I'm also going to multiply the 5 over x plus 3 by x plus 3. So this just shows that I'm multiplying everything on the right by x plus 3. So when I FOIL out these binomials, I'm going to get x squared. The outer product is 3x, plus the inner product is 4x. That gives us 7x. And then 3 times 4 is 12. And then for the second part, the x plus 3's cancel. And you're just left with plus 5, which gives us x squared plus 7x plus 17. The same thing that's on the left. So this just shows us that we can actually check everything. When you find your answer, along with the remainder, if you write this division statement, you can check to make sure that your answer and your remainder are correct. Because if they're not, you won't get the same thing on both sides, like we just did. So you can use this as a check to make sure that the answer you get and the remainder you get is correct. And we'll do some of that as a check. Okay? So let's divide p at x by x minus 2. We'll write that division statement. We'll talk about any restrictions on the variable, and then we will check our answer. But it starts with the division part. So we're going to divide x minus 2 into 5x cubed. Now, when you're doing this, a couple things you need to make note of. P at x has to be written in order of descending power. And also, if there's any missing powers, they have to be included with coefficients of 0. In this case, there are no missing powers. The highest power here is a power 3, that 5x cubed. There's also an x squared term, there's also an x term, and there's also a constant. So there are no missing powers, but we do need to switch the second and the third terms around because we have to write it in order of descending power. And as we go through this, you'll see why we would do that. Okay? So now, we're going to write something on top here. And whatever we write on top, we're going to multiply by both terms in front. But remember, we need a 5x cubed down here so that when we subtract, they cancel. So that's how we know what you're going to write on top. Whatever you write on here, up here, you need to multiply by the x and the minus 2. But we need a 5x cubed down below here, which means that this term must be 5x squared. Whatever you write on top, you're going to multiply by what's in front. And you see the 5x squared times the x gives you the 5x cubed that we need. That's how we know we need a 5x squared written on top. Because we need a 5x cubed down here so that when we subtract, they cancel. But we're also going to multiply the 5x squared by the negative 2, which will give us negative 10x squared. And now we subtract. When you subtract the 5x cubes, they cancel. Remember, you're subtracting here. For this next part, it's negative 13x squared minus negative 10x squared. The minus minus becomes a plus positive, so it'll be negative 13x squared plus 10x squared, which is negative 3x squared. And like we did before, that next term is copied down. It's brought down. Okay, so we need to figure out what we need to write on top here. Remember, whatever we write on top here, you're going to multiply by the x, and that's what comes down below. But we need exactly the same thing below the negative 3x squared as what's above the negative 3x squared. We need this down here to be negative 3x squared. So when we subtract, they cancel, which means that this term up here must be negative 3x. Yeah. We will on our next step. You can if you want, but it doesn't have to come down until the next step. So the reason we wrote this negative 3x here is because when we multiply by the x in front, you'll get the negative 3x squared. Exactly the same thing as what's above it, so when we subtract, they will cancel. But we also have to multiply the negative 3x by the negative 2, which will give us a positive 6x. And then we subtract. Negative 3x squared minus negative 3x squared. The minus becomes a plus positive. So it's negative 3x squared plus 3x squared. They cancel. But we're also going to subtract the 10x minus the 6x, which will be positive 4x. And now we'll bring down the last term, the negative 9. So we need to write something up top here. And whenever we write up on top, we're going to multiply by the x and the negative 2 in front. But we need a positive 4x here so that we subtract, they cancel. Because of that, this must be a plus 4 there. The 4 times the x in front gives you the 4x. As well, the 4 times the negative 2 is negative 8. And then remember, we are subtracting. 4x minus 4x cancels. But then the negative 9 minus the negative 8, the minus becomes a plus positive. It'll become negative 9 plus 8, which is negative 1. That's our remainder. So when we divided 5x cubed minus 13x squared plus 10x minus 9 by x minus 2, our quotient, our answer is 5x squared minus 3x plus 4, and we have a remainder of negative 1. So if we write our division statement here, we would say, and instead of writing out the entire polynomial, actually I'm going to, 5x cubed plus, minus 13x squared plus 10x minus 9, if that's divided by x minus 2, we got an answer of 5x squared minus 3x plus 4, and we got a remainder of negative 1, which is a ratio of the original divisor x minus 2. So there's our division statement. Before we do our check, let's state our non-permissive value. Because we're dividing by x minus 2 cannot equal 0 because we cannot divide by 0. So therefore, x cannot equal 2. So there's our restriction on the variable x. Because the denominator, when you're dividing by x minus 2, that's your denominator, it cannot equal 0. So to do our check here, we will multiply both sides by x minus 2. We need to get rid of the denominator on the bottom left here so that we're just left with the polynomial function. And we're going to multiply both sides by x minus 2. On the left, the x minus 2's cancel, and we just have this third degree polynomial. So we should get the same thing on the right. So I'm going to have to multiply the x minus 2 by the quadratic, 5x squared minus 3x plus 4. And I'm also going to have to multiply the x minus 2 by the remainder part, which was negative 1 over x minus 2. So on the right, those x minus 2's will cancel. If I multiply out what's left here using the distributive property, I'll first multiply all three terms of the trinomial by the x and then by the negative 2. I'll get 5x cubed minus 3x squared plus 4x, then by the negative 2 minus 10x squared plus 6x minus 8, and then the minus 1 that I'm left with when the x minus 2's canceled. So now if I just collect my like terms, I've got the 5x cubed that I need. Negative 3x squared take away 10x squared is negative 13x squared. That's the right second term. 4x and 6x gives us positive 10x. That's the right third term. And negative 8 take away 1 is negative 9. It's the same as the cubic polynomial that we started with. So therefore, we've just shown that our answer and our remainder is correct. Because if it wasn't, we wouldn't get the same expression on both sides. So there's our check. Okay? So in this next example, we're dividing a fourth degree polynomial by x minus 1. We're going to divide x minus 1 into. So there's an x to the fourth, there's an x cubed, there's an x squared, there's an x term, and a constant. Nothing's missing. It's in the right order. So I need to write something on top here to start with. And whenever I write on top, I'm going to multiply by the x minus 1 in front. But we need an x to the fourth below there, so that when we subtract, they cancel. Those first terms always have to cancel when we subtract. And because of that, we must put an x cubed up there. X cubed times the x in front will give you the x to the fourth. But you also need to multiply the x cubed by the negative 1, which gives us negative 1x cubed. And then we subtract. The x to the fourth cancel. And remember, you're subtracting. It's negative 2x cubed minus negative 1x cubed. The minus minus becomes a plus positive, so it's negative 2x cubed plus 1x cubed gives us negative 1x cubed left. And we'll bring down that next term, which is a positive x squared. So now we need to figure out what we're going to write next here on top. Whatever we write on top, we're going to multiply by what's in front, but we need a negative x cubed there, so that when they subtract, they cancel. And because of that, we must write minus x squared up there. Minus x squared times positive x gives you your negative x cubed that we needed there. But also you're going to multiply the negative x squared by the negative 1, which will become positive 1x squared. And when we subtract these, they're actually both going to cancel in this case. Negative x cubed minus a negative x cubed, the minus minus becomes a plus positive. So it's negative x cubed plus x cubed, they cancel. And the x squareds will also cancel. This will be 0, that'll be 0. So in this case, I'm going to bring down both the negative 3x and the positive 4. Lina, did you sign in? Thank you. Okay? So we need to write something on top there, and that something will be multiplied by what's in front, both the x and the minus 1. But we need a negative 3x there so they can cancel, and because of that, we have to put a negative 3 up there. Negative 3 times the x gives you your negative 3x. Negative 3 times negative 1 is positive 3. And remember, we're subtracting here. So negative 3x, take away negative 3x, minus minus becomes a plus positive. It's negative 3x plus 3x, they cancel. Also, 4 take away 3 is positive 1. That's the remainder. If we talk about our restrictions here, you're dividing by x minus 1, so that cannot equal 0. Therefore, x cannot equal 1. And our division statement would be p at x, which is x to the fourth minus 2x cubed plus x squared minus 3x plus 4. When that is divided by x minus 1, we get our answer, our quotient, which was x cubed, take away x squared, take away 3. And then we had a remainder of positive 1, which is a ratio of the original divisor, x minus 1. Now, before I finish this off, I just want to back up to the previous question and talk about one thing. Talk about why we had to rearrange it so that it was an order of descending power. The reason you needed this negative 13x squared as your second term is because when we multiplied by what's on top and what's in front, you got a negative 10x squared there. So that's why you need the second term to be an x squared term, because when you multiply, you get an x squared term there. And you could, if you wanted to, not rearrange the terms, left this positive 10x as the second term, the negative 13x squared as the third term. You just would have had to written the negative 10x squared under the negative 13x squared term. So it would have worked. But this just kind of keeps everything in the right order. So our check is done again by multiplying everything by x minus 1. Everything on the right by x minus 1. So on the left, the x minus 1s will cancel, and we're left with our original dividend. And we should get the same thing on the right when we multiply all this out. So on the right, there's two parts that need to be multiplied by x minus 1. The first being our divisor, our answer. And notice that there is no x term in there, and that's fine. Okay? It's just a result of when we subtracted here, both of these canceled. And so that's why there is no x term in our divisor. Also, the x minus 1s will cancel there, which will just leave us with a plus 1. So if I multiply these out, I'll multiply the trinomial first by the x, and then everything by the negative 1. So now when we combine our like terms, I've got my x to the fourth. Negative x cubed minus another x cubed is minus 2x cubed. That's the right second term. I've just got one x term, the minus 3x. And then 3 plus 1 is 4. Get exactly the same thing on the right as what we have on the left. Again, this verifies that our quotient and our remainder is correct. Because if they weren't, we wouldn't get the same thing on both sides. Okay, so we can always check these. This next question says the volume V of the nested boxes in the introduction to this section in cubic centimeters was given by V at x equals that polynomial function. What are the possible dimensions of the box in terms of x if the height h in centimeters is x plus 1? So the volume of a box will be the width times the length times the height. And we are told that the volume is x cubed plus 7x squared plus 14x plus 8. And that will equal the width times the length times the height, which is x plus 1. We are told that. So if you want to find an expression for the width and the length on the right side to get w times L by itself, we would need to divide both sides by x plus 1. They would cancel on the right, and we'd have an expression for the width times the length by itself on the right. We can get that by dividing out on the left. So we actually need to divide x plus 1 into 1x cubed plus 2x squared plus 14x plus 8. And that will give us an expression for the width times the length. So we'll divide that out using synthetic or long division. We need to have an x squared on the top. Must have x squared up there, because when I multiply it by the x in front, I will get the x cubed, so that when I subtract, they will cancel. But I also have to multiply the x squared by the positive 1, so it's positive 1x squared. And then we subtract. X cubes cancel. 2x squared minus 1x squared is positive 1x squared. And we'll bring down the next term, which is positive 14x. This next term has to be a positive x, because when I multiply by what's in front, x times x will give me the positive 1x squared, so that when they subtract, they'll cancel. And x times 1 is positive 1x. Did I write something down wrong? I'm sorry, it's 7x squared, not 2x squared. I wrote a 7 first time, but when I did the division, that should have been a 7x squared, not a 2x squared. So we'll fix that. So this is actually going to be 6x squared. So I apologize for making that mistake when I wrote that down. So 7x squared minus 1x squared gives us 6x squared plus 14x, which means you're going to have a positive 6x there. 6x times the x gives us 6x squared, and then 6x times 1 is positive 6x. So now when we subtract, the 6x squareds cancel. 14x take away 6x is 8x. And then I'll bring down that last term, that positive 8. And because we need an 8x down here, we must put a positive 8 up there. Whatever you write on top, you're going to multiply by what's in front. 8 times x is 8x. And 8 times 1 is positive 8. In this case, we get a 0 remainder. And what that means is that x plus 1 divides evenly into p at x. It divides evenly into p at x. Also, we were finding what w times L is. W times L will be the answer from the left, which in this case is x squared plus 6x plus 8, right? Which is a quadratic, which we can factor x plus 2, x plus 4. That means the width is either x plus 2 or x plus 4. The length is either x plus 2 or x plus 4, the other one. Whichever one is the width, the other one will be the length. So now we've written an expression that we could factor for the width and the length. So this is leading us once again into factoring third and fourth degree polynomials, which will tell us where the x-intercepts of that polynomial is, and allow us to sketch an accurate graph of that polynomial function. So we'll do the same thing, and I guess we should go back because it did say identify any restrictions. Because you're dividing by x plus 1, that cannot equal 0, so therefore x cannot equal negative 1. If we talk about the restrictions. And in fact, we can be a little more specific with our restrictions. Because we've got x plus 1 as one of our dimensions, we can also say that x plus 1 has to be greater than 0, because you can't have a dimension that's negative. If you have a negative dimension, it's going to give you a negative volume. Or if you have a negative dimension, it's saying that the length or one of the dimensions of this box is a negative number, which is not possible. So we would say that x had to be greater than -1. However, there are two other dimensions that we need to talk about. We saw that x plus 2 is an expression for one of the dimensions. That must be greater than 0. So x has to be greater than -2. And then finally, x plus 4, our third dimension, has to be greater than 0. So x has to be greater than -4. So we've got three statements here. We've got x greater than -1, x greater than -2, x greater than -4. We've got three different statements here. We're going to settle on the one that satisfies them all, which would be the very first one. All numbers greater than -1 are also greater than -4 and -2. So this would actually be our restriction that we would state. For this example, because the three dimensions represent the edge length of different pieces of that box, can't be negative. So this is a little bit different than just straight division, because the different parts of this polynomial actually represent the length of a piece of the box. It can't be negative. So we'll do the same thing for this one here. We've got the volume given to be x cubed plus 3x squared minus 30x plus 32. We're asked to determine possible measures for w and h in terms of x if L, the length, is x minus 4. Again, volume equals length times width times height. The volume is x cubed plus 3x squared minus 36x plus 32. We're told the length is x minus 4. We need to find an expression for w and h. So on that right side, we need to get the w times h by itself. We would do that by dividing both sides by x minus 4. They would cancel on the right, and w times h would be found by actually doing that division. Dividing x minus 4 into 1x cubed plus 3x squared minus 36x plus 32. Once again, that polynomial is in the correct order, descending powers, and there's no missing terms. If there was no x squared term here, we'd have to include it with a coefficient of 0. But there are none that are missing. We will see some eventually that do have missing terms, and we'll do that, but for now we don't have to. Okay, so I need to write an x squared up here, because when I multiply in front, I'll get the x cubed, and they'll subtract and cancel. But I also need to multiply the x squared by the -4. And now we will subtract. X cubes cancel. 3x squared minus -4x squared. The minus minus becomes a plus positive. So that'll actually be 3x squared plus 4x squared, which is 7x squared. And we'll bring down the next term, which is the minus 36x. I'll need to put a positive 7x there, so when I multiply in front, I'll get positive 7x squared. And then 7x times -4 is -28x. And I'm going to subtract. So the 7x squareds will cancel. Remember, we're subtracting -36x minus -28. The minus minus becomes a plus positive. So it's actually -36x plus 28x, which is -8x. And then we'll bring down the positive 32. And I'll need to put a -8 up there, because -8 times the x gives us -8x. And -8 times -4 is positive 32. Once again, when you subtract, they both cancel. You get a remainder of 0. And so that means that x minus 4 divides evenly into the polynomial. It also tells us that w times h is the quotient, x squared plus 7x minus 8. Once again, that quadratic can be factored to x minus 1, x plus 8, x minus 1, x plus 8. So there are the expressions for w and h. One of them is the width, the other is the height. And to get our restrictions, x minus 4 would have to be greater than 0, so x would have to be greater than 4. As well, x minus 1 would need to be greater than 0, so x would be greater than 1. And x plus 8 must be greater than 0, so x has to be greater than negative 8. We've got three different statements here. We would settle on the one that satisfies them all, which would be that x has to be greater than 4. All numbers greater than 4 are also greater than 1 and negative 8. So that would be the restriction on this. So tomorrow we'll draw some parallels between long division and synthetic division. One leads into the other. So we'll see how synthetic division works tomorrow. We're going to see that it's a much quicker, easier way to divide polynomials by a binomial. But today you can do some practice on long division. Do those questions on page 124, number 2 and 3. I will post the solutions to Google Classroom so you can check your answers. Okay. And a couple of you that missed the quiz